Hi folks, let's right a wrong. When we filmed the set screw test, we didn't have the Haas, and I know that we did it incorrectly, at least with the Cat 40 holder. So let's do this test the right way. Let's see what the measurements look like doing it the right way, and then let's talk about what happened over on the lathe last week. Welcome to a quick Wednesday widget update. All right, so same 3/4 inch Maritool set screw holder. Let's throw her in. And we'll jog down. And we'll come back in Y. And that was easy. That's a 10th of run out, probably not even. Actually, we can dial it in this way. That way we don't have to touch the indicator. And we should be able to just turn our spindle on at 20 RPMs. Look at that run out, folks. What is that? Half a 10? Awesome. So we know that that's good. Let's throw in that beautiful 3/4 inch Lakeshore Carbide end mill. We'll just leave the set screw holder in there. I'll just put it in there and tighten it, and we'll measure the shank run out, and this will give us a real test. Find our high spot in X, right there, and then let's see here. So let's come back in Y and preload it up to 0, tenths. Okay, so we'll call that a little over half a tenth, but let's just turn our spindle on. Go a little faster, see. A 10th of run out. How about that, folks? That's awesome. Let's stop it. And let's just look. In theory, the screw should be pushing it that way. So where the screw is should be our low point. Let's see if there's any truth to that. So that's about 1/10. And sure enough, it does get pushed back. I mean, half a tenth though. You can see it's the low point there. I love what I do. I sincerely love it. I love machining stuff. I love making the YouTube videos. I love sharing our experiences, our successes and failures with you guys. And you can't please everybody, and we make mistakes, and there's people who think we should do stuff differently. I tend to just try to do what I think is fun and what I enjoy, and hopefully you guys agree. The set screw video bothered me because I stayed objective, but I should have thought more about what was happening. I just should have. That run out didn't make sense. And in hindsight, it's so obvious. What was happening was we were dialing it in with the 4-jaw, but you can get something at an angle. You can get it to have almost no run out, but that only is true at one position in sort of Z, or the depth, if you will, on a lathe. So when we moved out, we had this shank, I'm sure, going off at an angle. And I want to thank Maritool. They sent me an email after they saw the video. They said, hey, FYI, here's how we do our calibration. And I really give them a lot of respect for that because, it's not fair of me to do a measurement on their tool when I didn't do it the right way and potentially put out a bad recipe or a bad result. And as you guys just saw, this thing is awesome, and we've been using them for our machine. We love them. So I just want to say thank you, and I made a mistake, and I try not to do that again. But it's a good lesson because I'm not the God's gift of machining, but there's a lot of folks out there that watch our channel that are new to this. And if there's a takeaway here, it's don't look for the answer you want. Don't assume everything is right. I tell that to people all the time at our training classes. When it comes to chatter on a tool, Don't assume it's just the tool. It could be the tool holder, it could be the runout, it could be the vise, it could be the work holding, it could be a bad piece of material. Don't make assumptions, and I am guilty there. I should not have made the assumption that that tool was in there when I was squeezing it on a relatively small area. The TTS shank that we did was nice and parallel or concentric, so that was a different test than holding on to a Cat 40 out here. It just wasn't good. So my apologies, folks. Hope you enjoyed. Take care. See you next Wednesday.